Hey everyone, and welcome. Today, we're going to crack open the rulebook for giving perfect instructions. We're going to go through the 5 essential rules that every single algorithm, which, let's be honest, is just a fancy word for a precise set of instructions, has to follow to work perfectly. But first, let me ask you something. Have you ever followed a recipe, followed it to the letter, only to end up with a total disaster in the kitchen? You did everything it said, but it just didn't work out. So why does that happen? Well, chances are the recipe itself was the problem. Maybe it was too vague, or maybe a super important step was just missing. And look, if that's a problem for us humans, you can only imagine what it's like for a computer. Computers can't guess. They can't fill in the blanks. They need absolutely flawless instructions. And that right there is what an algorithm is, a perfect recipe for solving a problem. So to build this perfect recipe, we're going to follow 5 key rules. We'll kick things off with our ingredients and the final dish. Then we'll make sure our instructions are super clear, that they actually have an end, and that there are no wasted steps. And finally, we'll wrap it all up with a simple 5-point checklist. All right, let's start with the 2 most basic building blocks of, well, any procedure, what you start with and what you end up with. In the world of algorithms, we just call this input and output.
So first step is input. And this is just the stuff your algorithm has to work with. The data, the materials, the little puzzle pieces it needs to get started. An algorithm can have a whole bunch of inputs, or sometimes it might not need any at all.
It's really just like a recipe, right? That may call for flour, sugar, and eggs. Or if you're doing a chemistry experiment, you need certain chemicals. But what about having 0 inputs? Well, think about an algorithm that just tells you the current date and time. It doesn't need any ingredients from you to do its job. It just works. Now, on the flip side of the process, we have the output. This is the result, the solution, the final thing you get. And here's the big difference from inputs. This part is not optional. Every single algorithm has to produce at least 1 output. What's the point otherwise, right? If you follow a recipe and you never actually get a cake, you've just wasted your ingredients. If a chemistry experiment doesn't give you a solution, you've wasted your time. An algorithm without a result is completely useless. Its whole purpose is to get something done. Okay, so we've got our ingredients, and we know what final dish we need to produce. But the real magic happens in the steps in between. And this brings us to our second rule, which is all about being clear. It's called definiteness. The rule of definiteness is simple, but it's really strict. Every single step in your algorithm has to be crystal clear. There can be 0 room for confusion, no vagueness, and only 1 possible way to interpret it. A computer can't just raise its hand and ask for clarification.
For example, a recipe that says add some salt, that's ambiguous. How much is some? A computer would just get stuck. But add 1 teaspoon of salt, that's definite. Same thing with cook until it looks done. That takes human judgment. An algorithm needs something precise, like bake at 350 degrees for 25 minutes. Every step has to be doable without any guesswork.
Okay, so our steps are perfectly clear. But what if they never stop? What if they just go on and on forever? That brings us to our 3rd super important rule, finiteness. Finiteness just means that your algorithm has to stop eventually. It could have 10 steps or 10 million steps, that's fine, but it can't run infinitely. There has to be a specific endpoint where it says, okay, I'm done, and gives you the output. And this is a really key distinction to make. An algorithm, like a recipe, is a task that has a beginning and an end. It's done when the cake comes out of the oven. This is totally different from something like a web server or a database, which is designed to just keep running 24/7. An algorithm has to have its own built-in stop sign. We're almost there. We have inputs and outputs, our steps are clear, and the whole process is guaranteed to end. The very last rule is all about the quality of the steps themselves. This is the rule of effectiveness. So, effectiveness kind of has 2 parts. First, each instruction needs to be so basic that a person could, in theory, do it with just a pencil and paper. No magic steps allowed. And second, and this is just as important, every single step has to have a reason for being there. No wasted motion. Yeah, this is all about efficiency. Why would you carefully chop an onion if it never even gets added to the stew? Why heat up a chemical in a lab if you never actually mix it into the final solution? It's just pointless. Every single instruction in an algorithm has to be a necessary, productive part of getting to that final output. So, let's bring it all together now. We've just walked through the 5 core rules that define any proper algorithm. You should think of this as your ultimate checklist, the 5 questions you can ask of any set of instructions to see if it's actually built to succeed. And here it is, the complete blueprint. You need input, those are your ingredients. You absolutely must have an output, that's the finished dish. The steps need definiteness, which means they're crystal clear, like 1 teaspoon of salt. The whole thing needs finiteness, so that oven timer will eventually go off. And finally, it all has to have effectiveness, making sure you don't waste time on steps that don't matter, like chopping veggies you never use. If you can master these 5 points, you've really mastered the fundamental logic of all algorithms. And that's really the bottom line, isn't it? At its heart, an algorithm is just a very, very precise recipe. If you break even one of these 5 fundamental rules, your recipe is pretty much guaranteed to fail, and your computer will have absolutely no idea what to do. So I'll leave you with this little thought. Now that you know the rules, which one do you think gets broken the most often in real life? Think about a project plan you got from your boss, or the last time you tried to assemble some furniture. Was it a lack of definiteness? Or maybe effectiveness, with a ton of wasted steps? It's a pretty cool way to see these principles in action all around you. Thanks for joining this explainer.